All right, everyone. Welcome to routing protocols. We're going to get to the basics of that. That's all. I'm going to give you more routing protocols than they actually tell you about for the CSEN. All right, because I'm just giving you the basics. Reversion 2 you just did. Simple. It's considered a distance vector. It's based on hop counts. You saw it, right? In the brackets, you saw the administrative distance and you saw the hop count, which was only one. So the maximum hop count with RIP is 15 routers. Once it gets to that 15th router, it goes to 16, unreachable. So you can only have 15 routers. Has a lot of routing loop issues. So it has a lot of mechanisms, which we're not going to get into, all right, that will avoid those routing loops issues. And it summarizes by default. By default. That's why you saw me put no auto summary. Meaning, please, Mr. Routing Protocol, do not summarize this address because it was really the 10114. It wasn't the 10000. So I'm telling you, send the correct subnet mask out on your updates so they know which way to go. Because if you don't, and you're running an all 10 network or an all class A or all class B, and you're subnetted, it's going to say, I'm going to just summarize this to the default class CIDR 8. It may go this way, that way, whichever way, it doesn't know. So that's why I put no auto summary, because it summarizes the updates by default. And the algorithm, obviously, that it uses, well, not obviously, but Bellman-Ford algorithm. Do not worry about it. It is physics. You're not going to do physics in your CSENT or CCNA or CCIE for that matter. Okay, you're not going to do physics. Just know that RIP version 2, any RIP uses the Bellman-Ford algorithm. That could be a question that they can ask. This is something that they may ask. Okay, the next one would be EIGRP. That is considered an advanced distance vector. That's a new name for it. All right, it used to be called a hybrid, but the people understand it. It's an advanced distance vector. Why is it an advanced distance vector? Because it not only is based on hop counts, as you can see here, that the max by default is 100, but it does go up to 255, which you can change. All right, but because it pays attention to bandwidth, delay, reliability, load, and MTU. Remember those? Those things are called K values, but we won't get into that, okay? But just so you know, heads up, all right? So if you have a larger network, you may run, or you should run actually, EIGRP, okay? Because it's based on autonomous systems. What is that? All right, you go router, EIGRP, and a number. You got from 1 through 65,535 autonomous systems you can use. All right, you can use multiple autonomous systems, which means that you need to do redistribution, or you can be in one single autonomous system and everybody talks to each other. They share the same routing table. You're each other's neighbors. You talk to each other automatically. Okay, and then of course its algorithm is called the dual, the diffuse update algorithm. That's what it's called, diffuse update. Again, do not worry. We're not worried about the physics. Okay, learn how this works first, and then probably the fixes will be easier. Okay, but that's these two routing protocols. And everything, like I said up here, depends on the size and complexity of your network. Look towards 10 years ahead. Where is this company going? Is it going to go anywhere? Am I going to do static routes? You saw doing static routes. Can you imagine doing that for 1,000 subnets? Not going to happen. I'm going to use a routing protocol. All right? So think about it. Think about it. All right, then we have Ospf, big routing protocol. Interior gateway routing protocol. Interior, okay? It's a link state, all right, not a distance vector. Doesn't care about hop counts or anything like that. Has no limitations, none, zero, okay? Uses areas. How many areas? Billions. 4.2 billions of areas. That's a lot of areas. And there's no limitations on how many routers you can have on each area. My Lord, that's a lot of routers. Be careful. And it uses the Dijkstra algorithm. The Dijkstra, another physics computation. Okay, don't worry about it. But know this, that if within an area, one link goes down between a router, all the routers in that entire area have to recalculate everything to get everything back up and running. Not good. Not good. So that's why you got to limit it. Yeah, limit the amount. I think the magical number is 50 routers per area, a number I have in my head. But just so you know, just so you know. All right. Again, this is not something that's going to be in the C-cent, but I'm giving you a heads up because the only thing they're going to be that I've seen in the book so far is RIP version 2. So heads up. And then you got the big boy, BGP, Border Gateway Protocol. This is an exterior routing protocol, and this is mainly used by ISPs. Some enterprises have picked this up, BGP version 4. They've picked this up. It also uses autonomous systems. It has public and private autonomous systems, okay? But it's considered a path vector. And like it says here, it's an exterior routing protocol, right? And it uses attributes, many attributes, in order to make its decisions on which way it's going to send the route. That's why it's considered a path vector, because it uses these attributes to make a decision on the networking that you're doing. All right, so those are your protocols. Now, the one that you need to be concerned right now for this very moment is RIP version 2, which is very simple. And there'll be a whole chapter on RIP version 2, so don't be concerned about it. So again, the important question you need to ask yourself, man, how big is my network? How complex? How many subnets do I have beneath me that need to route? And if I'm going out, what routing protocol am I going to use? Am I going to use RIP across the bandwidth, across a serial link? Am I going to use EIGRP across the serial link? If I only have 2 routers, should I just use a default route? Because you got to pay attention to the bandwidth. Because if you only have a T1 and RIP sends it out every 30 seconds, do you want the whole routing table? Distance vectors do this. Sends out the entire routing table on the updates. Do you want that to happen? So you got to make that decision. Okay? Well, that's it. I hope you understood. If anything, just re-go over the lecture and you'll understand. And there's going to be more practice ahead. So don't worry. See you there.